Your new book, Until the End of Time, is quite broad and ambitious in its scope. It's literally about the beginning to the end of the universe. So I was wondering if you could talk a little bit about the project of the book and what you were setting out to accomplish.
Well, I think you summarized it quite well. You know, my previous books all focused on particular areas of scientific insight, you know, trying to describe string theory or insights into the nature of space-time or the possibility of parallel universes. Those are the kinds of things I tackled in the past. This book is really meant to try to lay out in a coherent fashion the entirety of the development from the beginning, the Big Bang, if you will, to the closest that science can take us to the very end. And within that narrative, and this is very different from things that I've written about before, and no doubt you're familiar from having looked at the book itself, there's a focus on what happens when life emerges, and in particular what happens when conscious life emerges, and more particularly what happens when self-aware life emerges, stands up, looks around, and tries to make sense of not only how we got here, but tries to make sense of what we should do while we're here and what's going to happen into the far future. And the bottom line message, if you will, is that our footprint on the cosmological timeline is incredibly tiny when seen within the context of the totality, and how do we deal with that? And that's the theme of the book.
Starting at the beginning, I was reading the first few chapters of the book, and I was struck by the incredible elegance of the explanation of how the universe unfolded. You know, just as you've described it, it can basically be boiled down to two natural forces, entropy and evolution. I was wondering if you could talk a bit more about that.
Yeah, you know, when you have a project as big as trying to summarize from the beginning to the end, the natural thing is to find the overarching principles that allow you to organize a great many apparently seemingly distinct phenomenon, but to find them all fitting into some coherent pattern. And the two qualities that you describe are the two that I use to organize how things unfold. And I think many of these ideas are familiar certainly to this audience, but just to be complete, the second law of thermodynamics, as we teach our students, our physics students, describes how there's a tendency of the universe to go from states of order toward disorder, states of low toward high entropy. And indeed, we see that phenomenon playing out right along the cosmological timeline. But one thing that I've stressed within that rubric is that the increase in entropy does not demand or require or entail that there is the usual intuitive idea of degradation, of withering away, of falling apart, because you can have an overall increase in disorder while at the same time having local pockets of order emerge within that particular vector. And that's the vital reason why we have structure in the universe. You can have pockets of order forming within the overall tendency toward disorder. So that's, if you will, organizational theme number one. Organizational theme number two, as you note, is evolution. And I think most of us, when we encountered evolution for the first time, certainly when I did, we were taught it within the framework that Darwin and Wallace gave it to the world, which is in the evolution of species. And in that setting, we understand well how it is that a given collection of life forms can fan out to a very broad, larger collection of life forms through the properties of mutation and natural selection. But that already assumes life exists. So what I describe in the book is a perspective on natural selection and evolution that has been developed in more recent times, where it can take place right at the level of atoms and molecules. So I describe a certain kind of chemical combat, not species combat, but chemical combat, in which molecules learn the trick of replication, and those molecules that replicate faster, more stable, more efficiently are the ones that will grab more of the natural resources in the environment, and therefore their molecular form will dominate the demographics. And then molecular mutations, where the copying mechanism is imperfect, can yield other molecules, which may be better or worse, but those who are better at replication will, of course, now dominate from that point forward. So in a sense, you have evolution is building up structure. Entropy, at some level, is assisting it when it's creating local pockets of order, but in the far future, as the narrative describes, ultimately works in tension with evolution, degrading structure as we head to the very far future.
That tension was so fascinating to me because when you're thinking about it intuitively, you think of the two principles as being in somewhat of an opposition to each other, that entropy is just this progression towards disorder, like how are we evolving these complex structures of life? But it was really fascinating to think about it in terms of like, life is basically a side effect of the way that entropy unfolds with, being countered by gravitational forces, et cetera.
Yeah, I mean, so there's 2 points in that question. The latter is that without the force of gravity, there'd be no structure at all. Mm-hmm. So in the Big Bang, particles, energy is all moving in an outward direction. And if it was simply the kind of entropy and second law of thermodynamics unfolding that we teach in a standard undergraduate course, where we, for instance, talk about molecules in a room. Those molecules in a room will simply spread out and fill the room. And if that was what was happening in the cosmos, the particles in the Big Bang would simply fill out and spread throughout the entirety of space. And there would be no structures that would exist. It's the force of gravity which radically changes that story. And of course, in an undergraduate course, we rarely talk about gravity when we're teaching thermodynamics and statistical mechanics. But gravity, of course, has the tendency to pull things together. And because of that, you can actually reach higher entropy states by not letting the particles simply fan out, but rather having some of them come together and yield structures like stars, in the process squeezing out the entropy potential within that matter by generating heat and light that travels outward. So you get a pocket of order and an overall increase of entropy in the environment. And we, in some sense, are just like stars. We are collections of particles that come together, allowing the entropy potential of matter to be increased by virtue of the fact that we take in raw material from the environment, we burn it up, we give off heat to the environment, we keep our entropy low by virtue of injecting entropy into the environment. So you're right, we're kind of a sideshow that the universe leverages to have matter reach its entropic potential.
And talking about the emergence of life, you had this really great, succinct forward quote about the emergence of life. Life is physics orchestrated,
yeah,
which really stuck with me. So that's just 4 words. Can you, like, you've talked about this a little bit. Can you elaborate a bit more?
Yeah, we are special. Life is special in some ways, right? We can think, we can feel, we can react in various ways to the environment. But one of the beauties of thinking about life and consciousness within the cosmological unfolding is that we see deep continuities, right? Just as a star is a collection of particles that is fully governed by the ironclad laws of physics, we each are collections of particles that are fully governed by the ironclad laws of physics too. Now, our organization is more exquisite compared to the organization, say, in a tabletop or even in a star, and that allows us to realize behaviors that are unavailable to the table or to the star, and that certainly is welcome. That's a good thing. But the bottom line message is we are all bags of particles governed by the laws of physics. And this was a statement that I made on The Late Show with Stephen Colbert. It just sort of came out in a heated conversation, to which he responded, "Hey, that's a great pickup line." And it is, actually. You should try it out, guys. But that's what I mean by life is physics orchestrated. We are physics that is manifested in a highly coordinated manner. And that's really the only distinguishing characteristic of us compared to the inanimate objects in the world.
So related to that, what I found fascinating also was given all the mysteries of the universe that we've already solved about how, Earth came to be, the solar system came to be, one of the biggest mysteries that seems like we're still working out is how a big bag of particles governed by the law of physics achieves consciousness and self-awareness like you were talking about earlier.
Yeah.
Do you have thoughts on how that study is going and what might be some of the answers to that question?
Well, it's the big mystery that nobody has answered as yet. And there are many theories that are out there. In the book, I describe those that I find the most compelling or the most radical, perhaps, as well. You know, the big question, the so-called hard problem of consciousness, as articulated by David Chalmers, is how could it be that a collection of mindless, thoughtless particles like electrons, quarks, and protons can somehow come together and in their aggregate turn on the lights? How can those particles moving inside a gloppy gray structure inside of our head somehow create the sensations, the responses, the thoughts that you and I and everybody else have every moment of their lives? Where in the world does that come from if the ingredients themselves show no evidence of having any such qualities? Now, one answer to that question, in fact it comes from David Chalmers and others as well, is maybe the particles do have consciousness. You look at that, you're like, really? Are you going to really put forward an idea like that? And that's the extent to that some people are led to through beating on this problem and not being able to make any progress, or any progress that feels like it's heading in the direction that will answer the question. So could it be that electrons and quarks have some proto-conscious quality, and only by virtue of putting a lot of them together do you get sort of macroscopic consciousness, the thing that you and I can recognize happening inside of our heads? Now, I am not one who is moved by that perspective. I should say, if it were true, I think it would be thrilling. I'd love it to be the fact that we've long since missed that electrons are thoughtful entities. How spectacular would that be? But I don't see any reason to go to that extent. In fact, the model that I think is worth thinking about is the conversations that were happening in the 1800s about life, even in the early 1900s. You can say the same thing. How can a collection of lifeless particles somehow come together and switch on and become animate? How in the world could that be possible? And in the old days, the view was it is not possible. You have to inject something else on top of the particles, some vital life force, vitalism. Nobody talks like that anymore. And the reason is because as we've gotten better at understanding the structure of life, most people who think about it have come to the conclusion that it's just particles and the laws of physics and chemistry and biology, but that all reduces to physics, and that's all that you need. And I think that at some point in the future, I don't know, 50, 100, 1,000 years, whatever, we will come to a similar realization about consciousness, and we'll kind of look back and smile at how in the 20th and 21st century we injected so much mystery into this quality of the world, when in reality it was nothing more than particles and laws. And look, once you guys develop a truly conscious AI system, I don't know how you prove that, but once you do develop that, I think that will also be a moment where, like, yeah, you organize things correctly and the thing starts to think and feel. That's just what matter does.
One thing that your book touches on a lot is that there's this companion philosophical question that goes along with that. As bags of particles that are entirely governed by physical laws, how do we have consciousness, but also how do we have any sort of free will?
Well, we don't.
Right.
That's the end of that. I said that flippantly, but I really do believe that, as you see in the book. However, there are so many different definitions of what free will is that you have to take a statement like that, I would say, with a grain of salt, or you really have to plumb it very carefully to understand the kind of free will that I'm talking about. I'm talking about the freest kind of free will. I think that's what most of us intuitively imagine when we think that we have free will. We imagine that we are the ultimate autonomous authors of our actions, right? We can think about the world, we can be affected by the world, but ultimately when we act, that action is originating within us. We are not mathematical beings whose strings are pulled by physical law. And that just is incoherent. We are collections of particles fully governed by physical law, and every thought that we have, every action that we take is nothing but those particles playing out the dictates of the mathematical equations, the physical laws. So that version of free will, and I think it's the intuitive one, seems to me to be completely incoherent. Now, what happens when philosophers and scientists think about these ideas, you can go in a variety of directions with that sort of realization. And the direction that I go is a long-standing and well-respected approach called compatibilism, which is basically finding a new kind of freedom that you argue, and as I argue in the book, is as valuable as the old version that isn't true, and in that way plays the role of a substitute for the thing that we lost when we recognize that that traditional free will is gone. And as I describe in the book, my view, it's not a view that others haven't articulated in one form or another, is simply that what makes us special is not that we can transcend physical and mathematical law. We can't. But rather, because we are so ordered and so well choreographed, we can execute a spectacular range of behaviors that are unavailable to most objects in the world. And you know, I mean, right here, even sitting here right now, I just articulated a thought through a sentence. And I take a step back and I'm like, yeah, my particles just did a reasonably good job of saying what my other particles were trying to articulate. And I sit back and I'm like, thank you, particles, for doing that, or thank you, physical law, for allowing my particles to do that. And in that way, I actually feel a degree of gratification for the fact that my particles did something that I'm happy with. And when my particles do things that I'm not happy with, I similarly feel a degree of remorse. But that's what's going on. And all of it comes from physical law.
What you touch on in the book as sort of a corollary to that is like it certainly feels like we have free will, and
Yeah.
maybe that's what really matters, that we can have this conversation and it doesn't feel like I'm being ventriloquized to have this conversation. It feels like these are my actual thoughts.
Yeah, no doubt there is some evolutionary advantage to these collections of particles having the sensation that they are in control of their actions. Presumably, beings that have that sensation are maybe able to navigate the ancestral environment better than collections of particles that did not have that sensation. And so it's deeply ingrained in everything that we do and everything that we think. But you have to bear in mind that evolution did not equip us to understand the true nature of the world. Evolution equipped us in order to survive, and those are two radically different propositions. So you need to bang really hard on qualities of the world that you hold true to make sure that you haven't been led to that perspective by the survival value that it had over the course of 100,000 generations in the past. And in fact, you can even go further. Take quantum mechanics, right? I think none of us, at least I don't, I'd be interested if someone felt differently, none of us have quantum mechanical intuition in our bones. You know, if I pick up, an object and I throw it to anybody who's out there in the audience, they'll know how to put their hand and catch it because we have Newtonian physics in our bones. You don't have to calculate trajectories to figure out where to put your hand. But if I were to fire electrons at you, you'd have to do the quantum mechanical calculation because you would not know where to put your hand to get the highest probability of capturing the electron. Why is that the case? 100,000 generations of our forebears, those who had Newtonian intuition, survived. Those of our forebears who sat down on the African savannah and said, let me think about Schrodinger's equation. They got eaten. So they did not propagate that genetic tendency into the gene pool, and therefore it takes this kind of concerted effort to go beyond what we are programmed to do in order to figure out other qualities of the world. And I think a similar thing applies to free will. We think we have it, we have the sensation of having it, but that's all that it is, a sensation.
Talking about survival and evolution in the central section of the book, you also have a really interesting discussion of human areas of inquiry like religion and the arts that don't necessarily have, direct connections to our survival of, getting food, reproducing, et cetera. There's some really interesting discussions about potential evolutionary antecedents to those areas. And I was curious your thoughts about, why we write poetry, why we perform music, why we, have monotheistic beliefs, et cetera.
Well, there are a lot of interesting questions in there, and as you note, there is a long-standing and continued discussion or debate about the degree to which these kinds of behaviors may have been seeded by the same kind of seeding that gives us Newtonian physics intuition, right? Could it be the case that we tell stories? I mean, what happens? We leverage language early on in the history of our species. We learn how to communicate. And do we take that capacity and immediately translate it into communicating information from one member of the species to another. Well, that's part of what we do, but we spend a whole lot of time, there's evidence going back thousands of years, of course, we spend a whole lot of time getting together and exchanging fictional accounts that both members of the conversation know have nothing to do with the external world, and yet we feel compelled to listen to these stories, to repeat these stories, to modify these stories, to pass these stories on. Why in the world do we do that? What a waste of time, it seems like. Wouldn't it be better that we, sharpen a few more spears or gather more fruit and nuts rather than sitting around and talking nonsense to each other about things that never happen in the real world? Now, you could say maybe it's just an artifact of having a big brain. A brain gets big enough, that's a good thing from an evolutionary perspective, but maybe a side effect of having a big brain is a brain that just never shuts up. Right? It never stops telling stories because it just can't get enough of that kind of activity. But others have suggested that maybe there is an evolutionary basis of this in the sense that by telling stories to each other, we kind of fire up a flight simulator of engagement with the world, where we are able to have a whole variety of experiences that are safe, but allow us to imagine how we might respond if we encountered those kinds of experiences in the real world. So maybe those of our forebears who exchanged stories in this manner were the ones that were better able to respond quickly, nimbly, and effectively when unexpected things happened in the world, because they had this body of fictional accounts that they in some sense could draw upon and in that way guide their behavior going forward. And there's a whole analogous version to that kind of story, highly controversial story, that applies to other activities, the ones that you mentioned, religion and creative expression. Like, why would we spend time, chiseling figurines? Why did we spend time painting cave walls, right? I mean, you look at some of the caves that have been painted, and for one of our forebears to have to travel sometimes kilometers in darkness through underground waterways to find various surfaces on which they would paint various kinds of beings that didn't even exist in the real world, perhaps. Why in the world would they do it? It's the same kind of question with storytelling. And again, a whole variety of potential evolutionary perspectives have been put forward. Maybe it allowed groups to cohere more fully than they would otherwise. So in competition with other groups out there in our hunter-gatherer past, maybe those are the ones who triumphed. Or perhaps creative expression is just the brain's way of firing up its innovative qualities. It can sharpen its own ingenuity by taking things in the real world and rearranging them in distinct patterns, or by just firing up and examining things that have nothing to do with the real world, but nevertheless allow creative juices to flow. So those are the kinds of things that evolutionary psychologists have explored, and I integrate these kinds of explanations within the context of the book because, as we started out early on, when you see entropy and you see evolution as these entwined braids that take us from the Big Bang through the formation of stars and planets to the emergence of life, to the emergence of consciousness, do these principles continue to guide what happens as we go forward when you've got self-aware beings now part of the equation?
What was really interesting for me, a recurring theme throughout the book, is that our narratives happen at different levels of abstraction.
Yeah.
So you can go sort of drill all the way down reductionist-wise to the quantum level, where it's just all about probabilities of locations of particles. And as humans, those sorts of narratives of the world are not especially compelling if we're just, it's like a bunch of particles here, a bunch of particles there, et cetera. You can move up a level to the Newtonian level and talk about motion and momentum and all those aspects of physics. And what I found fascinating about looking at it from that perspective is that you can work, as you go up the levels of abstraction, that's where you can fit in things like the arts and religion, et cetera. What are these narratives that mean something to us, and how do we, an ongoing process of how we understand the world?
Yeah, no, I think that really is a central theme of what I describe in the book, because in order to have the fullest understanding of the world, the universe, you need to use the kinds of descriptions, the kinds of stories that are most relevant to the kinds of questions that you happen to be asking. So look, I mean, if you're interested in the basic ingredients and the fundamental laws, then certainly the reductionist account that physics has provided is the one that you should use. But if you're interested in life, you don't really want to go down to the level of molecules and atoms, because you want to deal with the aggregates that allow us to more fully examine what life is. It's very hard to see life at the level of an individual electron. You need to synthesize your reductionist account to have a fuller story of what life is at the level of chemistry and biology. And then, as you describe, I go further than that, because the richest accounts allow us to go up in scale and think at the level of psychology, the level of neuroscience, which gives us some insight into why conscious beings do the things that we do. And when you get to religion and you get to storytelling and myth-making and creative expression, these kinds of accounts are more closely aligned with how we intuitively think about the world. And it's really through this nested layering of the stories that you gain the most full tapestry of what it means to be human. The thing that I would emphasize is that even though these stories are each told in a different language, and even though these stories are relevant for a different class of questions, a point that I stress in the book is that the stories need to be mutually compatible. And oftentimes that doesn't have a great deal of purchase, but it does on certain kinds of questions, such as the free will question. So you can say, well, free will is just something that happens at the human level. You don't never need to talk about what's happening down at the reductionist level. And that is an incoherent statement as far as I'm concerned, if you're talking about the kind of free will that I was articulating early on, because that notion of free will has tentacles that reach right down to the reductionist account. And to say that you have free will and you don't need to talk about the stuff down here is cutting out the very thing that informs the answer to the question of whether we have free will. So it's a mutual compatibility of stories that give us insight into different layers of reality. And as you build them up, you have the fullest account.
So, spoiler alert for those who haven't read the book yet, there's a bit of a downer in the end, as the book ends by narrating what the demise of the universe is going to look like. So could you give us some insights as to what it's going to look like when the world ends?
Yeah, it's interesting that you describe it as a downer. And I understand where you're coming from. There's an article that just published in Time magazine today. I was reading it this morning, and it sort of starts off the first paragraph being how bleak it all is in the far future. But I think, as you realize from going to the end of the book, I would not interpret it that way.
Yeah.
But I'm happy to lay out some of the milestones in the far future of the universe, just to get a feel for why it might appear to be dark. And the way I do that in the book is I make use of a metaphor that I think is useful for grasping the incredibly long timescales that you need to consider in order to really fill out that story. I imagine, and I ask you to imagine with me, that the Empire State Building is our metaphor. And each floor of the Empire State Building, imagine, represents a duration 10 times that of the previous floor. So I'm using a spatial metaphor to talk about time in the far future. And in this scheme, everything from the Big Bang until today extends from the ground floor to just above the 10th floor, 10 to the 10 years, 10 billion years since the Big Bang. And from here, we just go exponentially far into the future. I'll take you through a couple of the floors. By floor 11, we find that the sun will swell to over 200 times its current size, swallowing up the inner planets, possibly the Earth. By floor 12, the distant galaxies will rush away faster than the speed of light, leaving us floating in a sea of darkness. By floor 14, most stars will use up their nuclear fuel and will fade to black. By floor 19, the Earth, if it wasn't swallowed up by the sun back on floor 11, it will now spiral into the dead sun because it loses energy through gravitational radiation. By floor 30, most stars and most galaxies will fall into the galaxy's central black hole. By floor 38, protons, the very heart of matter, will likely disintegrate, meaning that all complex matter by that point goes away. By floor 50, if there are any cogitating beings left in the world, which is hard to imagine as matter falls apart, but let's just, for argument's sake, imagine that there's some thinking being that still exists out there in the cosmos. That being will think its final thought by the 50th floor, because it will burn up in its own entropic waste generated by the very process of thought itself. between floor 68 and the peak, black holes, which will be the only things that are still hanging around in a bath of particles, they will evaporate through Hawking radiation, leaving us floating in an endless sea of particles wafting through an ever colder, ever larger universe. That's it. Now, that's where the bleakness,
Yes,
no
that's the
doubt,
downer part, yeah.
no doubt comes from. But you know, here's a different way of thinking about it, which is there has been a tendency throughout human history to imagine that there is some external purpose, some external meaning, and all we need to do is go out and find it or carefully listen, and the universe will provide us with those sorts of answers. And this kind of, look, that could be true, but there's very little or no evidence for that. And this kind of a narrative from the beginning to the end, I think, makes it quite clear that there is no ultimate purpose, there is no ultimate meaning. We are the product of the purposeless, mindless laws of physics playing out from the Big Bang until today and on to the far future. But having said that, think about the fact that we are here by virtue of the fact that a whole collection of quantum processes stretching back to the Bang, a virtually infinite collection of quantum processes, each of which could have turned out that way instead of this, turned out in just the right way to allow us to exist, which means that against spectacular odds, we somehow are here. And it's not just that we're here, we are organized, as we discussed, in the right way, that through what I like to describe as a flitting burst of activity, we can create beauty, right? We can illuminate mystery. We can experience wonder. And to me, that gives a deep sense of gratification that really almost borders on reverence for the fact that we are here and can do these things. And in a world that is deeply distressing at times, incomprehensible in various ways, shocking in other ways, to me that kind of reverence injects something that is vital and valuable, and to me in the current environment, something that I think adds an incredibly deep layer of satisfaction in an otherwise distressing world.
My favorite section of the book at the end was talking about all the wacky things will happen as matter disintegrates, et cetera, just with quantum probabilities and the vast expanses of time. Like eventually, you know, weird things will happen. Maybe bobbleheads will materialize in deep space, et cetera. My favorite was the discussion of the Boltzmann brains.
Yeah, Boltzmann brain is a very curious idea, and it is a relevant idea well beyond the peak of the Empire State Building. So you can say, you know, I sort of took you from today up to the 100th floor, if you will, of the Empire State Building, but is that truly it? And what you recognize is that the combination of virtually unlimited time together with the probabilistic nature of the quantum laws yields a very potent combination. Because if quantum mechanics says that something can happen, even with an incredibly small probability, if you wait long enough, you're virtually assured that that unlikely event will at some point happen. And when it comes to the nature of thought, the most probable, although incredibly unlikely event that the universe allows to happen is that those particles that I mentioned that are floating through the void, every so often, a couple then can smash into each other and stick together, or through the energy of their collision, create a new particle. And every so often, a third particle can come in. Sometimes they'll fall apart, but sometimes it'll happen again. If you wait long enough, one of the processes that can happen is particles can just randomly come together to yield a brain. A brain that can be imprinted by virtue of the particle arrangement with the very thoughts that you or I currently possess. I mean, so imagine that my brain, which is just a collection of particles in a certain configuration, is reproduced in the far future out there in the void. Well, that brain floating out there perhaps would think that it's at Google having this conversation right now, but it's completely confused because it just came together through the random motion of particles. Now you have to wait a very long time for this to happen. One of the estimates that I give in the book is, the exponential Empire State Building took us up to 10 to the 100 years, a familiar number for everybody here. But the length of scales that you'd have to deal with for Boltzmann brains is 10 to the 10 to the 68, a double exponential. But if you've got unlimited time, who cares how long it's going to take? There's nobody sitting around saying, when is that brain going to form in the void? There's no other brain waiting for it to happen. So this is a curious idea. Physicists typically find it a very disturbing idea, not because it's weird, right? We're all happy with weird stuff. What's really disturbing about it is if you ask yourself, or if I ask you perhaps, like, where did your brain come from? I know it sounds kind of personal, but I don't mean it in I'm not trying to intrude on your personal space, but I think most of us would give an account that would say, look, I was born, and my parents, they were born, and you'd sort of trail it all the way back, perhaps even go back to the Big Bang. And that's an interesting story. But here's the thing. The number of brains that can be created in that conventional manner is relatively small compared to the number of brains that can form in the void if you're waiting for an effectively infinite amount of time. So if you ask yourself, by sheer dint of probabilities, are you one of those brains that formed in that very rare process, which started at the Big Bang and yielded the brain in the manner that you've described, or is it more likely that you're one of those brains that's floating in the void? And since there's so many more of those compared to the conventional approach, the odds would suggest that it's more likely that you are a brain floating in the void who just told a very quaint and beautiful story about starting at the Big Bang and being born in the traditional human manner, but a story that's completely false. And the disturbing quality of that conclusion is, take my brain, imagine it's now actually formed in the void. That brain thinks it understands the laws of physics, quantum mechanics and general relativity, because that brain seems to remember having taken quantum mechanics and general relativity, across the water over there at Harvard, and seems to recall looking at all the data that confirm those theories, but all that's fake. All of it's false, because the brain just came together right now. So that brain now can't trust anything at all. So there's skeptical nightmare that happens. The brain can't even trust the very reasoning that led us to conclude that the brain should form. So you've undercut all rationality when you allow these Boltzmann brains into the story. So we physicists tend to use this possibility as a diagnostic tool, that if our theories allow for this to happen, we have to find some means of dealing with that conclusion or modifying the equation so it can't happen in order that we don't ruin rationality itself.
I appreciated that there were some reassurances in that section of the book that the likelihood of us actually being Boltzmann brains right now was still relatively low. There was a chance that Boltzmann brains might not form.
And those are the kinds of theories that people develop. They try to develop theories where perhaps the universe ends before there's enough time for a Boltzmann brain to form. So you find physicists who start to be excited about the demise of the universe because now you have a more self-consistent story that you can tell if the timescales don't reach, say, 10 to the 10 to the 68 years into the future. That's only one way that people have tried to deal with this conclusion, but it certainly suggests the extent to which people are willing to go in order to avoid the problem.
I think it's a good time to open it up for questions.
So you mentioned that your compatibilist perspective about basically coming up with a more reduced but still basically mapping to human intuition of what freedom means. Would a conscious AI with like full self-knowledge of its own code and memory be able to have any kind of free will under that perspective?
Well, again, if you're using the definition of free will that I'm describing, the answer would be yes, because if it was sufficiently sophisticated, it would have a broad range of behavioral responses that it could execute in response to various stimuli that it encountered in the external environment. And that, to me, is the freedom of relevance when we're talking about us humans, and therefore presumably can be generalized to any other structure that has that capability. The point is, it's not freedom from the tyranny of mathematical laws. It's freedom from restrained behavioral responses that has long constrained the inanimate world. So if you can take the inanimate world and allow its behavioral responses to blossom, then you're in exactly the same situation. And that entity, by this definition, would have free will.
But if it has perfect self-knowledge, it can see the code paths that led to like any action. So you could say that given a certain input, it's completely deterministic in a way that completely cuts out quantum anything.
So you will note that in my remarks, I never use the word deterministic. I never use the word indeterministic. And in our discussion of free will, I never invoked quantum mechanics. Why? It's irrelevant. What do I mean by that? Well, often people say, in a classical world, then it's fully determined, and clearly there's no such thing as free will, right? You tell me the positions of the particles now, you tell me their velocities, and you just turn the Newtonian crank, and that will fully determine what happens in the future. Clearly, no room for a volitional being to intercede in that progression. Then people come along and say, but with quantum mechanics, all of a sudden there's a window opening, because now it's not fully determined, only the probabilities of one or another outcome are determined, and they try to slip free will in there. But let's think about it. If you have an indeterministic, probabilistic set of laws, then you have random outcomes governed by the measures of quantum probabilities. Is a random outcome somehow a place where you're going to put human freedom? I don't think so. When we have an intuition about free will, we're not imagining someone's flipping a coin back there and that's how our actions are being determined. And if that's what's going on, I don't feel any better than I do in the classical description of the world. So deterministic and indeterministic is a complete red herring. It is irrelevant to the conversation. What matters is the progression of the world governed by laws? Is there a lawful progression regardless of what those laws are? And if the answer to that question is yes, then the kind of free will that I was talking about at the outset does not exist. And so it doesn't matter the system. We are that AI system that you're talking about. That we happen to be flesh and blood, who cares? We're exactly the same situation. And if I could look internally and fully understand the workings of my brain, my code, it wouldn't change the conversation one single bit.
Have you heard of mangled worlds?
Angled?
Mangled.
Mangled. I don't think I have.
It's a theory in quantum mechanics where basically when two probabilities get sufficiently small, they interfere with and destroy each other. Just this is one of the theories I was wondering if you'd heard about addressing why Boltzmann brains might not happen.
I'm not familiar enough to give a coherent answer to that particular approach, but again, much as we were describing before, people have invoked a whole variety of different techniques to try to argue that the kinds of processes that would yield the Boltzmann brain will never be realized. None of them at the moment have sort of caught fire and convinced the community that this is no longer an issue that needs to be thought about. So it's very much an ongoing question.
Jumping back a little bit to the discussion of where things like storytelling and art making came from, it seems like there's a tendency in these discussions of where did these things come from to talk about them in terms of ors. Maybe humans tell stories because this, or maybe, are there any frameworks that you know of that take these ideas? Obviously, it might not be an or it might not be an exclusive or. Yeah. It might be an inclusive or. Are there any frameworks that talk about looking at these things in conjunction, whether the probabilities are higher, if telling stories gets you this and this and this?
Right. There are a variety of different voices that chime in on a question of that sort. Some have a very sort of adaptionist perspective, which basically says anybody who tries to invoke survival value to these kinds of behaviors is overstepping the bounds of evolutionary ideas and telling just so stories that try to give us some semblance of coherence for the behaviors that we see human beings engage in. And many of those folks would say that's a big mistake. It's a big mistake. One should simply recognize that evolution and natural selection have their place, but if you try to push those ideas further to truly gain an understanding of all of human behavior, you're just pushing it into a domain where it no longer applies. So you have to be very careful. And I think the most thoughtful of researchers and practitioners try to maintain that care. And I think that's where a lot of those ors come from. Because, look, it's pretty hard to do experiments, to, say, rerun the evolutionary unfolding, to really see why it was that individual X did Y or seeded that behavior into the gene pool. And so I think the best that you can do is to make arguments that seem convincing. And like one of the traditional arguments of this sort is, and the most familiar, I would say, it's often used as the gold standard, if you will. Why is it that we have a tendency to like sweet foods and fat foods? Answer: those of our forebears in the ancient environment who stocked up on fruits and nuts were the ones that could survive when times turned lean, and therefore that predilection for those kinds of foodstuffs was seeded into the future gene pool. So we go and we have Haagen-Dazs or we have whatever, you know, and it's no longer viewed as a health promoter, but the link to our evolutionary past seems quite convincing. To make that same kind of argument about religious affiliation, the telling of stories, creative expression is much, much harder. So for instance, you know, Steve Pinker, you know, one of the world's leading thinkers in this kind of domain, his view is that music making and most art making, he does not consider to have an evolutionary basis. In fact, he famously calls them kind of cheesecakes of the mind, right? You know, they're foodstuffs of no value that leverage, or parasites, if you will, on ancient qualities that did have adaptive value. If we were sonically attuned in the ancient environment, then we'd understand our environment better, right? If you could hear a footstep, or if you could hear some lion or leopard, you know, if you were really attuned sonically to the world, then presumably you had some survival value associated with that. And he views music as something that leaps beyond the adaptive value of that sonic sensitivity to kind of just push our pleasure buttons in a way that has no adaptive value whatsoever, just like eating cheesecake has no adaptive value in the modern world. And there are some who agree with that, some who don't. I, however, find it quite convincing to think about the role of these activities in developing and sparking and nurturing the innovation, that the ingenuity that allowed us to create the things that allow us to be in this room right here. So I'm not particularly convinced by his perspective, although I totally get it, and that's where, again, one of these big ors comes from. So in the end of the day, one thinks carefully about these arguments and comes to some intuitive understanding of which way of thinking about the world seems to be most convincing. And it's very hard to nail it down. I mean, you know, I come from a world where you make your case by calculating, say, the electron's magnetic moment to 10 decimal places, then you compare it decimal by decimal to the observations. That world is not one that's easily extended to the kinds of questions that we're talking about now.
We have an online question as well. How much do we know about what our primitive ancestors, say 100,000 years ago, thought about the meaning of existence? And when did we start thinking that way?
Yeah, so it's sort of a similar version of the question that we just had, which is not much, right? I mean, you know, all of recorded history, you know, it goes back, you know, whatever, 5,000 to 6,000 years, right? And you know, in the beautiful way of thinking about the past, the cosmic calendar that Carl Sagan introduced, where you imagine that all of cosmic history from the Bang until today is in a single calendar year, right? The Big Bang happening on January 1st. You ask yourself, when did modern humans appear? Well, we appeared at 11:40 p.m. on New Year's Eve, right? And you ask yourself, where did recorded history start? Well, that happened at 10 seconds to midnight. So if you want to go further back, it's very hard. And therefore, you're led to speculate, or you're led to try to imagine a pre-recorded history that naturally, seamlessly melds into the history that we know about. You say things like, look, if we as a species, or some of the members of our species, wrote the Epic of Gilgamesh, you know, from 3500 BC, Well, if in those early days we were spending time, chiseling into cuneiform tablets some story about a demigod who was out there trying to find immortality, you have to imagine that we were also telling stories way before that, even though they were in an oral tradition that wasn't recorded. And does that seem reasonable? It seems reasonable to me. It's hard for me to imagine that, we've started to chisel. Okay, now the first story. We've never had practice telling stories before. So that's the kind of reasoning that you use, but it's very hard to give the kind of convincing explanation that we're familiar with, like I was saying, from, say, fundamental physics.
I noticed the title of your book is Until the End of Time, and I'm wondering, since entropy basically contributes to the direction of time, do we reach a state of maximal entropy where particles just don't interact with each other, and does time cease, or does it fluctuate back and forwards then?
Yeah, so it's a great question, and one has to really bear in mind that the second law of thermodynamics, this increase of entropy, is not a law in the conventional sense of the law. What do I mean by that? What I mean is the second law of thermodynamics should really be called the second tendency of thermodynamics, the second overwhelming likelihood of thermodynamics, because it's a probabilistic statement that says it's overwhelmingly likely that if particles are seeded out to the world, they will evolve in a manner that increases their entropy. But that tendency can be violated, right? I mean, if I take a handful of 100 pennies and I throw them on the floor, we all know that it's highly likely that it'll be roughly 50 heads or 50 tails in that grouping. We also know, however unlikely, that it could turn out that they're all heads. We wouldn't want to bet on it. We wouldn't want to hold our breath waiting for it to happen. But that move toward order, that move toward low entropy is not, in some sense, in violation of the laws of physics. It's just highly unlikely. And similarly, the move toward order in the universe is just an unlikely move. It's not one that the laws of physics prevent. So even if we do reach this state that looks like maximal entropy of particles filling the void, much as we were talking about with the Boltzmann brains, those particles can, like the pennies, they can do the analog of landing all heads. If we wait long enough, the pennies will land all heads. If we wait long enough, some structure, however unlikely, however much it violates the second law of thermodynamics, will happen. So you never reach a state of ultimate stasis where absolutely nothing can happen. You reach a state where it's increasingly unlikely for things to happen, where the timescales for those unlikely things gets longer and longer.
So we have one more online question that relates to stuff we were talking about earlier with mutual compatibility. Scientific advances tend to contradict traditional explanations. What new sources of ultimate meaning have arisen? For example, human space colonization, efforts towards artificial superintelligence, or the simulation hypothesis.
Yeah, so it's not obvious to me that scientific advances tend to contradict traditional explanations. Some scientific advances do, but a great many scientific advances confirm our intuition. It's just our intuition is built up on a particular scale, and the advances that are relevant to that scale will confirm them. When we go beyond those scales, we find things that are quite unfamiliar. So I think of the various possibilities that the questioner asked. The simulation hypothesis, I think, is perhaps the most radical of all, which is, again, familiar to you guys here, the possibility that we're in some futuristic supercomputer run by some kid in a futuristic garage, and all that's happening here is we are playing out the programming that that kid in the garage has set in motion. Now, again, do I consider that a likely scenario? I don't. I find it a useful scenario to think about because it is a version of reality in which there is a version of a God. That kid is the God, created this world, but it's not supernatural. That kid is governed by the laws of physics at that higher level of reality, and that would be a version that would be completely compatible with accounts of the world that imagine that there's some intelligence that guides the cosmological unfolding. Nick Bostrom at Oxford makes a very interesting argument along the lines of the Boltzmann brain argument that I gave before, which is, it is very difficult to create a real universe. It's hard to spark a new Big Bang. But it might in the far future, or maybe now if we're in that simulation, it may be very easy to create simulated worlds. You know, just fire them up one after another after another. So if I ask you, are we in the real universe that came from the real Big Bang, or are we in the simulated universe where there was a simulated Big Bang? Again, if you're willing to just go with the odds, there are many more simulated worlds compared to real ones, and therefore if you throw a dart, you're more likely to hit a simulated world than a real one, and therefore perhaps it's more likely that we are right now in a simulated world. Again, do I buy that? Not in a deep way, but I find it a very interesting argument to think about. In fact, people have written papers, how should you behave if you think that we are in a simulated world? And if you guys think about this for half a second, I think you'll come to the same answer that was in this paper, which is that kid doesn't want to waste CPU on someone who's boring. No wallflowers, right? They get eliminated from the reality. So you better be pretty damn interesting if you want to continue existing in the simulation.
Again, going back to this interesting idea of why do we do art and storytelling.
Yeah.
I liked your idea of evolution and entropy in interplay. When we do art, when we make music, aren't we creating a bunch of entropy that if we didn't do it, we would create less entropy?
Through any action at all,
Right.
the answer is absolutely yes. And that gives us a nice uniform way of thinking about all of activity, whether it's activity of a life form or activity of a star, right? It all fits into that overall progression, modulo the unlikely possibility of entropy going down, that over long time scales we believe will happen. So from that perspective, you don't gain much insight into the kinds of behaviors that you were making reference to. But if you then use the other strand of the explanatory chain, if you then use evolution, and if you buy into, not say the Steven Pinker argument, but if you buy into the possibility that these behaviors go all the way back. I mean, there's example of rudimentary musical instruments go back 60,000 years. Right? So, you know, if you imagine that it was these kinds of activities that really distinguished our creative capacities, then you start to have a coherent account that you can at least begin to develop. I mean, one way of saying it is this. If there were a humanoid race, say on this planet, of Vulcan-like beings, and I don't mean that derogatory to the Vulcans, I have all due respect for them, but you know what I mean by that is beings that were, you know, completely rational, only spend their time on things that will enhance their own survival in the most obvious flat-footed way of getting more food or having better shelter. And you have those beings in competition with beings more like ourselves who waste time making, archaeological instruments that we then can find, or painting cave walls, or telling stories. I suspect that it's these more irrational beings that win out against the more rational ones, because it's only through those kinds of behaviors that you come upon striking new insights that allow for innovation. And it's that willingness to waste time, it's that willingness to allow the creative juices to flow freely that ultimately, I think, allowed us to be the dominant species in the world.
So you don't think there'd be a lot of difference in the entropy created by us versus the Vulcans?
Yeah, from an entropic standpoint, there wouldn't be much of a difference, because if you defocus your eyes, and sometimes I do this, right? If you defocus your eyes and you look around this room, and all you see are collections of particles banging into each other, fully guided by mathematical equations, whether those particles are telling stories, creating art, or just sort of sitting around watching television, it doesn't make any difference to that defocused view of the world. And that's the reductionist account. It's a correct account. It's not a particularly useful account for understanding the kinds of questions that you were asking. And it's a kind of leveler in that sense. And if you then want to go beyond that leveling, you have to refocus your eyes and really focus on what actually those collections of particles are doing.
Thanks so much, everyone, for coming.
Thank you.